Hey guys, today I'll be explaining the Chapter 9 Physics quiz. It's really easy, it's filled with new stuff, so you might think it's hard, but no, in reality it's very easy. So let's begin with question 1. For each interaction, state whether the work done by the acting force is motive or resistive. Drag and drop the correct terms from the box below. Okay, so they're asking whether it's motive or resistive. So to explain this, let me give you this quick example. Imagine a cart, okay, going up a hill, right? And then imagine another cart going down the hill, okay? Now, I'm sure you've seen this in movies or cartoons, but when the character is like on a bike, for example, and he tries to go uphill, it's really hard. He goes really slowly. But when he reaches the peak over here and then suddenly he goes down in like extremely fast speeds. Now, why does this happen? Because the weight, which is the gravity, that's pulling it down, and the direction is going up. So they're opposite. So that means it's resistive. Okay? While over here, the weight's down and the direction is down. It's motive here. Same. That's why when it goes down really fast. When it goes up, it goes slow. Because they're opposites here. Resistive, it's resisting. The gravity is resisting it. It's not allowing it to go up. So it's pulling it down while it's going up. So they're resisting each other at the opposite directions. So it's really hard. While the other one, the motive is in the same direction as the weight, as the gravity. So it's very fast. That's it. Now for this, weight of the book as it slides down, so it's motive as it goes down. And then as it is pulled up, it's resistive because weight is down while it's pulled up, so opposite directions. Now for these two, whenever you see friction, whether it goes up or down, it will always be resistive. Okay? Both of them, whether it goes up or down, because there's friction, and friction opposes it. Whatever direction it goes, friction will always oppose. Alright? That's all. So if it goes down, if it goes up, friction will go like this. If it goes down, friction will go like this. Okay? That's basically it. Now that's it for question 1. Let's go for question 2. A person is putting a box along a rough floor. Okay. Here they're asking for the work done by the frictional forces. Okay. By the frictional forces. So that means the forces that oppose the work. And work, what's the rule for work? Force times distance, right? We have force as 25 newtons times distance as 2. Now we'd say, oh, it's 50. No. They said the work done by the frictional forces. So the force will be negative because they're asking for frictional forces done by frictional forces, right? The work done by the opposing forces, so it will be negative. Negative 25 times 2 is equal to negative 50 joules. That's it. Now for question 3, for each example, state whether the interaction described occurs with or without energy transfer. Drag and drop. Okay, so now let's imagine this. So you can just demonstrate it. A book resting on a table. Okay? Now look around your desk, your bed, your shelf. You'll see objects just lying there. There's nothing going on, no movement, no energy transfer. So there is no transfer occurring. Now for a bucket that's being lifted upward at constant speed. Okay? It's being lifted upward, so potential energy is increasing. Gravitational potential energy is increasing, right? So the energy is transferred. Now, a rock travels uniformly through open space. In space, there's no forces acting on it. And it's traveling uniformly, so there's no energy transfer. Okay? Let's clear it up. A ball is in a free fall. Okay, now this ball, it's in a free fall, right? So there's no energy transfer here. There is energy transfer here. Because as it's going down, potential energy, gravitational potential energy, is decreasing. So there is energy transfer. You always illustrate it like this. If there's energy transfer, what's going on? What's the energy that's being that's decreasing or increasing. Here, potential energy. Always, for any question like this, always think logically. Don't memorize, understand. Alright? So that's it for this question. Now to question 4. My notes. Okay. Two bodies be isolated system. Okay. Now I'll just explain it really quickly. I'll demonstrate it. So, because there's a bunch of questions about isolated systems. Now they give us two bodies, P and Q, right? An isolated system. What does isolated system mean? Basically, imagine it as a rectangular thing. That's not literally what it is. I mean, I'm just giving you an example so you can quickly understand it and solve it in the exam. Isolated system basically means the energy inside does not interact with the energy outside. Okay? That's its whole goal. Because they want to, the purpose of isolated systems is to test the interaction between two bodies, okay? How much energy does is being transferred, how much is one body losing, how much is the other body gaining. That's the purpose of isolated systems. It's like an experiment. Okay? They're not allowed any energy from outside or inside to leave or enter. Okay? So that's it. Now, to give you a quick representation, this number is just an example. Okay, it's not something to be memorized. It's just a number. Let's say P gained 50 joules. Okay, let's say the system has 50 joules. Okay, P gained 50 while Q lost 50 upon interaction between the two. So once they interacted, P gained the 50 joules from the Q while Q lost the 50. So in other words, we can say that Q gained negative 50 and P gained positive 50. That's it. So when let's say they ask you for the net energy between the two bodies, you're gonna add them up. P plus Q, right, equals the net. P gained 50, right, positive 50, while Q gained negative 50, which means it lost. Same meaning, but they just different signs. It's the same meaning in the end. So let's say if P gained 50 and Q gained negative 50, 50 plus negative 50 is 0. That's what it means. Again, like I told you, don't memorize, understand. This is how it works. They interact. This gains this amount of energy, and this gains the opposite signs, but the same number. Add them up, you get 0. That's why it's 0. So let's look at the options. Energy gained by P is equal to negative energy lost by P. So it's like saying positive P is equal to negative P. Get what I mean? And positive P is equal to negative becomes positive P. So they're equal. This is correct. Energy gained by P plus energy gained by Q. Like I said, P gains, let's say 50, while Q gains negative 50. 50 plus negative 50 is 0. Same thing here. Energy lost by P, energy lost plus energy lost by Q. P loses negative 50, while Q loses 50. Add them up, you get 0. That's it. So this is correct, this is correct. Now to question 5. Okay. Do bodies P and Q form a system? After some interactions, Q has lost 80 and P has gained 60. Okay. So here, you can see that the value changed. What does that mean? This is not an isolated system or closed system. It's not. It's open. So imagine that the rectangular thing I gave you before, the representation, imagine there's like an open gap. And there's the two bodies inside. So the energy leaves the system. So like they said, Q lost 80 joules, so minus 80, and P has gained 60. So where's that 20? That 20 left. So we can say the system has lost 20, the system has gained negative 20, the same meaning. Now, P gained 60, and Q gained negative 80, right? Because it lost 80, so it gained negative 80. That's it. For question 6, Two bodies, P and Q, form an isolated system. After an interaction with Q, the energy gained by body P is positive 50 joules. The energy gained by Q in the interaction is what? Since P gains 50 after an interaction, that means it got it from Q. So Q gained negative 50, meaning it lost positive 50 joules. And the net change, as we said, one is 50, one is negative 50, add them up, you get 0, right? That's it. Okay, now a block of mass 2 kg initially moving at 10 meters per second. Okay, and a force of 3 Newton directed opposite to the displacement. When the block is displaced by 5 meters, its speed given to the nearest integer becomes what meter per second? Okay, so we're gonna use the work energy theorem. Work equals delta kinetic energy. What does that stand for? Force times distance, which is work, equals delta kinetic energy. 1 over 2 mv squared minus 1 over 2 mu squared. Okay? So now, let's substitute the given values. They want us to find the final velocity, which is v squared here. They want us to find this. So let's substitute the values and solve for v squared. Now force is 3 times distance 5. Remember, they said directed opposite to the displacement. When it's opposite, it's negative, right? It's opposite to the displacement, the direction. So it's negative, it's opposing. So negative 3 times 5 equals 1 over 2 times mass 2 times v squared, what we're trying to find, minus 1 over 2 times 2 times u squared, which is 10, the initial velocity. You get negative 15 equals 1 over 2 times 2 is 1. 1 times v squared is v squared, minus 1 over 2 times 2 is 1. 1 times 10 squared is 100. Okay, so you flip 100 to the other side, becomes 100 plus 100. So v squared equals 100 minus 15. That becomes v squared equals 85. 85. You radicalize both of them, you get v equals 9.2. But they wanted to the nearest integer, so you make it v equals 9. That's it. Okay, so they give you mass, they give you force, they said a longer reference string parallel to the floor. As a result, the body moves through 6 meters and the speed of the body increases from 2 meters per second to 4 meters per second. Okay, so they gave us everything required to use the work energy theorem, which is work equals delta kinetic energy. Right? Work here is force times distance. We have force as 3 times distance 6 equals 1 over 2 times mass 1 times v squared. They said it becomes 4, so it's 4 squared, minus 1 over 2 times 1 times it was 2, so initial velocity is 2 squared. Now just solve. 18 equals 1 over 2 times 1 is 1 over 2. 1 over 2 times 16, which is 4 squared, equals 8 minus 1 over 2 times 1 over 2 times 1 over 2 times 2 squared is 4, so it equals to 2. 8 minus 2, so it becomes 18 equals 8 minus 2 is 6, right? Now what's it called? We got this is the, oh yeah, by the way, I put the work of tension here. This is the work of tension, okay? We don't need that right now, we only need this one. The change in kinetic energy, what they asked for. Okay, so change in kinetic energy is 6. Now, the work done by friction on the body is what? Alright, so now that we found the change in kinetic energy, which is 6, which is equal to the network. Okay, we have network now, so that we can do this work of friction equals network, which is 6 minus work of tension. We found it as 18, remember? 6 minus 18 is negative 12. So the work done by friction on the body is negative 12. Which makes sense because friction opposes, so negative. Now they're asking you for a magnitude of the force of friction, so the force of friction itself. We can easily do this by work equals force times distance. We have work as negative 12 equals force what we're trying to find, times distance, which is 6. So it's going to be negative F, because F will be 2. So negative 2 times 6 equals negative 12. That's the force of friction. But be careful, they said magnitude. When they say magnitude, they only want the number, they don't want the sign. So you only put 2, okay? So yeah, you use the work energy theorem and you just solve. Okay, that's it. Now for question 9. Okay. Oh, okay, we got an MGH question. A box of mass 15 kilograms is lowered through 2.50 meters. Use G equals 10 meters per second squared. They want the work done by gravity. Okay. Guys, there's two rules. Positive MGH and negative MGH. Many people get confused. When to use positive or negative? Okay. So listen. They're asking for, first of all, you see what they're asking. The work done by gravity. So they're asking what's the work done by gravity. They could ask work done by person, work done by pipe, work done by car. Here they're asking work done by gravity. So you take into consideration the force of gravity and how it affects the box. Now we're saying the box is being lowered, right? And gravity is already pulling it down. So the direction of motion and the force, gravity, they're in the same direction. They're both going down, so that means it's motive, it's positive. So we use positive MGH. You got it? But if it was, let's say, it was lifted and they're asking work done by gravity, it's down. So that's opposite. So it's negative, resistive. So we use negative MGH. So it always depends on what the question is asking. But here they're asking what's work done by gravity as it's being lowered. So it's positive, the same direction. So use MGH equals mass 15 times gravity 10 times height 2.5. 15 times 10 times 2.5 is equals to, oh, I did something wrong in the calculator. 15 times 10 times 2.5 equals 375. Okay, that's the work done by gravity. Got it? Now, question 10. A small ball of mass 0.20 kilograms is projected at 10 meters per second parallel to the ground at a height of 8 meters. The only force acting on the ball is the force of gravity. Take G equals 10 meters per second squared. Okay, let's look at part A. The work done by gravity on the ball by the time the ball hits the ground is what? Okay, so they want the work done by gravity on the ball by the time it hits here. Okay, so what we can do here is MGH. They want the work done by gravity, right? We say they're asking as it goes down and gravity goes down. So we use positive MGH, right? Since it's going down and gravity is down. So same direction, positive MGH. Okay. Now mass 0.20 times, this is MGH by the way. Okay. Mass 0.20 times G10 times height 8. So 0.20 times 10 times 8 is 16. This is the work done by gravity, and indeed it is 16. Okay. Now let's look at the second one. According to the work energy theorem, the kinetic energy of the ball is about to hit the ground. Okay, so they want the final kinetic energy. But we can't find it without the speed. They didn't give us the final velocity. The third one, it's not showing, but they're saying the speed of the ball as it hits the ground is what? They're asking for a final velocity. So we're going to solve C and then we're going to solve B. We're going to find the final velocity first. Okay, so we can use the work energy theorem. We got the work as 16 equals 1 over 2 times 0.20. We're going to use delta kinetic energy rule. Times V squared, what we're trying to find, minus 1 over 2 times 0.2, 0.20, times 10 squared, the initial velocity, right? 1 over 2 times 0.2 is 0.1 times v squared minus 1 over 2 times 0.2 is 0.1 times 10 squared. What's 0.1 times 10 squared? Which is 100. It's 10. So 0.1 times v squared is 0.1 v squared. This is equal to 16, by the way. Minus 10. We move 10 to the other side. We get 0.1 v squared equals 10 plus 16, which is 26. Divide by 0.1. Divide by 0.1. You get 26 divided by 0.1 is 260. So v squared equals 260. Okay? So since we got 260, we just radicalize both of them because we want the value of v. So you get v equals radical 260, which is 16. It's 16.12, but we just put it at the integer like this. Okay, so the final velocity is 16. Now that we found the final velocity, the answer of C, now let's find B, final kinetic energy. So we're just gonna use 1 over 2 mv squared because we only want the final. We don't care about the initial. They don't want the change. They only want one of them, which is the final. So let's use the final velocity in this one. 1 over 2 times mass 0.2 times v squared. V here is what's it called? 16. We got it as 16, right? 16 squared. So 16 squared times 0.2 times half is equal to 25.6, which we rounded to 26. And that's the answer. Okay, that's it for question 10. Now moving on to question 11. Okay, so they are saying a student of mass 40 kilogram goes into the basement located 3 meters below the ground. Use g equals 10 meters per second squared. Okay, so whenever you solve gravitational potential energy questions, there always needs to be a reference, a zero level, which is this one. A reference is where the gravitational potential energy is 0. Okay? So we got the reference. Now they're asking what's the GPE of the person under the 0 level. Okay? So what we're gonna do? We're gonna use MGH. Right? So if since we're gonna, this is different from what's called the other questions. We just directly apply MGH. We don't care if it's positive or negative. It's just MGH. Okay? This is different. We're trying to find the position here. So mass is 40 times g, which is 10, times 3. You get it as 1200 joules, but they want it as kilojoules, right? So you divide it by 1000, you get it as 1.2 kilojoules. Okay, so since it's 1.2 kilojoules, we don't just put 1.2. They said below 0 level, so logically you'd say it's negative because anything below 0 is negative. So it would be negative 1.2. Anything below 0 level is negative. Okay, so that's the answer. Negative 1.2 kilojoules. Now for this question, they're saying this construction worker has a mass of 90 kilogram and is moving through the floors. The height of each floor is exactly 4 meters. So, and they gave us a reference level in the first floor. Okay, so what do? The gravitational potential energy, let's solve A first. Gravitational potential energy of the worker standing on the ground floor is what? 3.6 kilojoules, right? Negative 3.6. How do we get that? Let's solve. Again, we use MGH. We don't care if it's negative, positive. This is position. They're not asking the work done by what. No, they're asking for the position. So we use MGH here. Just MGH. Okay? Mass 90 times G 10 times height 4. You get it as 3600 joules. But I want it in kilojoules, like this previous question. So you divide it by 1000, you get 3.6. But since standing on the ground floor, this is below the reference level, which is the zero level. Reference means zero level, okay? Reference level, zero level. So since it's below the reference level, it's negative. So it will become negative 3.6 kilojoules. Now for part B and C, they're asking for the GPE of the worker standing on the first floor. We said the first floor is where the reference level is, which is 0. Okay? Now for part C, the GPE of the worker standing on the third floor is what? Okay, so let's look at it like this. Ground floor, we said it's negative 3.6, right? First floor is 0. Then second floor, we keep adding 3.6. It's 3.6. So third floor is 3.6 plus 3.6, which is 7.2. So the answer is 7.2 kilojoules. That's it. Now for question 13. Which statements are true about the GPE? Select all that apply. Okay, now GPE is always given with respect to reference level. Like I said before, always, when you have GPE questions or anything related to GPE, there always needs to be a reference level, which is basically the 0 level. Always. Okay, that's the first one. Now for the second one, the change of the GPE equals negative of the work done by gravity. What does this mean? Basically, they're saying delta gravitational potential energy equals to the negative of the work done by gravity. So when they say this is these two are always opposites. Okay, I mean opposite in sign, not in value. They're always opposite in sign. So if GPE was negative, work would be positive. But if its work is negative, GPE would be positive. They're always opposite to each other. So it equals the negative of the work done by gravity. If they said the negative change of the GPE equals positive of the work done by gravity. Alright? That's it. Now for this is correct. Now for the GPE of a body is proportional to its mass. Okay. Basically they're saying GPE equals mgh, right? It's proportional to its mass. Why? Because when we multiply the mass by 2, for example, this will increase also. So it's proportional to its mass. That's it. And guys, for this rule, I just want to give you an example so you can properly understand. Imagine a man standing on a building on a balcony, okay? And this man drops a basketball down, okay? Once he drops the basketball down, gravity will put it down also. Direction of motion is down and gravity is down, okay? So now, this is positive mgh, of course. But that's what we're looking for. What we're looking for is the effect it has on the potential energy. Here, it's positive mgh, right? But here it's losing potential energy. You got what I mean? Since it's losing potential energy as it goes down, so you can say potential energy is negative, while the work is positive, because it's in the same direction, right? That's what it means. Same thing if we throw the ball upwards. Okay, let me just erase this. Same thing if we throw the ball upwards. Not same thing, sorry, it will be the opposite. If you throw the ball upwards, gravity will still act downwards, right? So the rule is work done by gravity. Gravity is down while the direction of motion is upward. So they're opposites here. So it's negative mgh, and in this case, once it goes up, the potential energy is increasing because the GPE is increasing because it goes up. Okay? So in this case, GPE is positive, while work is negative. See, this is the roots of mgh. They're saying potential, they're always opposite to each other. Always imagine this example. A man throws the ball down, okay? He throws the ball down, gravity is acting on it. This rule always involves gravity, okay? So gravity acts on it, it goes down. Direction of motion is down. This is positive mgh. So work here is positive. So immediately, once you know that work is positive, you know that GPE is negative because they're always opposite in sign. You got it? That's it. Now for question 14. A ball of mass 1.2 kg is moving vertically 2 meters above the ground at 5 meters per second. Okay, so they're saying a ball is moving vertically upwards. Okay? So they didn't say anything about gravity, so we can say that this is positive. Okay? Because it's going up. Since we're something is lifting it. So basically the force is also going up. So it's positive here. And then, okay, they want the mechanical energy. Okay, this is a new one, but it's an easy one. Mechanical energy. What's the rule for mechanical energy? It's kinetic energy plus potential energy. Okay, so you have to find both of them, then add them up. Let's find kinetic energy first. 1/2 mv squared plus potential energy is mgh. Okay, now 1/2 times mass 1.20 times v squared, it's 5 meters per second, so it's 25, so it's 5 squared, right? Plus mgh, I'll just erase this, plus mgh, mass is 1.20 times 10 times height is 2. So you do this, 1/2 times 1.20 is 0.6 times 25, you get 15 for this one. 15 plus 1.20 times 10 times 2, you get 24. So 15 plus 24 equals 39. That's the total mechanical energy of the ball, 39 joules. That's it. See, very easy. A pump is used to lift 200 kilograms of water by the height of 6 meters in 2.5 minutes. Okay, so they were asking for the work done by the pump against gravity. So basically they're saying the pump, okay? It's used to lift 200 kilograms of water, right? So the pump is lifting it upward. But so since it's lifting it upward, it's against gravity. But that doesn't matter here. We're just looking at the pump here. We're not asking the work done by gravity. They're asking the work done by pump, which is against gravity, obviously. But that does not matter here. Anyways, now, since they're asking something about related to gravity, you use mgh. Okay, since it's going up, positive, right? Now, mgh, mass 200 times gravity 10 times height 6. 200 times 10 times 6 is 12,000 joules. But I want it in kilojoules, so you divide by 1,000, you get 12 kilojoules. Now, for the second one, they're asking for power. What's power? Power is work over time, seconds and joules. So since work in joules, we're gonna convert it back to joules. It's going to be 12,000 over time in seconds. We got 2.5 minutes. You can just multiply it by 60, you get 150. Or if you want to be manual, you can just do it directly. 2 minutes is equal to 120 seconds plus 5.5. 0.5 is half a minute, so 30. So 120 plus 30 is 150. You can do it both ways. I prefer this one. Anyways, so 150. So 12,000 divided by 150 is 80 watts. Power is always measured, expressed in watts. Okay, that's it for this question. Now for question 16. A car is moving at constant speed along a horizontal road. Its engine exerts a force of 5 kilonewtons, moving the car through 880 meters in 80 seconds. Okay. So the work done by the car engine to two significant figures is what? Alright, let's quickly. They want the work, right? So it's force times distance. We have force and distance. We'll do it 5 kilonewtons times 880 meters. You get 4,400 kilojoules, right? Now they want it in megajoules. And how do you convert kilo to mega? What's the conversion factor? You divide by 1000. So you divide by 1000 here, you get 4.4 megajoules. Okay, that's for A. Now for part B. The power developed by the car engine to two significant figures is what? Okay, they want power. So power, we know it's work in joules over time in seconds. We have work, which is which we got it. They want it in joules, right? So wait, never mind. They want it in kilowatts, so we just put it in kilojoules. Okay? You always look at what they want at the end. They want it in kilowatts, so keep it in kilojoules. You don't need to convert it to joules. So now, work in kilojoules, you just put it directly. You got it as 4,400 over time, because 4.4 megajoules. You got it in kilojoules, it's 4,400 before you convert it to mega. So 4,400 kilojoules over time in seconds. So 4,400 divided by 80 is 55 kilowatts. That's part B. Now for the last question, question 17. Okay. A column crane lifts 320 kilograms of construction materials up 12 floors in 120 seconds. The height of each floor is 3.2 meters and G equals 10 meters per second squared. The power developed by the crane is 1024. Okay, so they want the power developed by the crane, work over time, right? So we're gonna try to find the work first. To find the work. So since it's a question related to the height and gravitational potential energy, you find the work by doing MGH. Again, doesn't matter if it's negative, positive. This is not a question that really delves into that part. It's a question asking for the position. Okay? So position. Okay? So you do 320 times 10 times total height. You don't put 3.2, that's only height of each floor, one floor. So you want the total height of all 12 floors. So you multiply 3.2 times 12 equals 338.4 over time in seconds, 120. You multiply all of this together, you get 122,880 over 120 divided by 120, you get 1024 watts. Okay, that's it for this question. Just one last note, guys. Like I said, MGH, don't get confused. Oh, what if, should I use negative here, should I use positive? It depends what the question asks. Here they're asking for the position only, the work. Okay, so if they only want the position, you just use MGH, doesn't matter. Okay, so yes, if they only it doesn't matter here. But if you do want to delve into that, it's the column crane lifts it, okay, up. Alright, and they're asking the work done by the crane, and the crane, it's just it does an upward force. It's lifted upward and the force is upward, so it's positive if you want to be fancy. Well, it doesn't really matter here. Okay, questions like, there's another question we just went through. I want to just go back to it quickly. Here, the pump, yes, it used to lift 200 kilograms of water, right? Like I said, here this doesn't matter. The pump used to lift it. Alright? Since, well, I guess يعني you can involve it if you want to. It's used to lift it, right? If it's lifting it upwards, and they're asking the work done by pump. So its direction of motion is up. It's being lifted up, and it's the force is upward. So they're both same direction. It's positive. That's why I use positive MGH. Okay. I suggest صراحة you always try to find the direction just to be safe. You know, you never know what questions you might encounter. Anyways, hope you understood. If you did not understand anything, go over the video or contact QSC members, either through the group chat or privately. It's okay. All of it, it's the same thing. It's all the same for us. So don't hesitate, don't be shy. Reach out, ask the group, and we'll always do our best to help you. Okay? Hope this video helped and wish you the best of luck in your exam, and see you later.